problem. So the problem is search in the rotated sorted array. So there is an integer array nums which is sorted in ascending order with some distinct values. So prior to being passed to the function, nums is probably rotated to an unknown pivot index. So 1 less than equal to k, which is less than. So for example, like 0, 1, 2, 3, 4, 5, 6, 7 might be rotated at pivot index 3. That means it will be rotated as like 0, 1, 2, 3. From 3 onwards, it will go 0, 1, 2, then it will come like this. So it is basically like a circular connected way. So the array is basically rotated, I guess. So given the array nums after the possible rotation and an integer target, return the index of the target if it is in the nums, or -1 if it is not in the nums. So we have an array that is given nums, so it is possibly rotated, and an integer target is given. So we have tried this algorithm in of log n time. So if the target is found, we have to, it is basically searching for a target. If it is found, we have to return that index. If it is not found, we have to return -1. But the small challenge here is the array is possibly rotated. So here we have an array given 4, 5, 6, 7, 0, 1, 2. So the target is 0, 0, 1, 2, 3, 4. In the fourth position, 0 is there. Similarly, here we have to find the target 3, which is not in this array. So we are returning -1 for this test case also. So the first solution, as we can basically think, is brute force solution. We will search for it from 1 to n. And if the target is found, we will return the index. But the problem lies there is the time complexity. We can get a more optimized solution of log n. So as I have said before in my previous videos, when it comes to searching, first just go thinking about how binary search works, because it works with half the time of a linear search. So we can get the result is in of log n time. So, but the only condition is it should be sorted. The array should be sorted here, but the problem is it's not sorted. Now 4, 5, 6, 7 becomes 0, 1, 2, but actually it's sorted. The array is sorted and it is rotated. That's the only mistake. So we have to handle that condition 0, 1, 2, 4, then 4, 5, 6, 7 it comes. Similarly here also 1. So that's how the array will be, but it's already sorted. So that's the challenge here. So we'll try finding a solution for that. So suppose this is the array 4, 5, 6, 7, 8. Okay, no, 4, 5, 6, 7, 1, 0, 1, 2, no, 0, 1, 2. So this is the array. So we have to find the first one is target 0. So let's search with this. So as we have to find the target 0, and as I have said, while I am applying a binary search for this. Okay. So we have to apply a binary search for this. So at first I will search the middle. This will be the low and this will be the high. So this will be the middle value. So the condition that we can think of here is we have a middle value. We can't directly go for left or right, because look, the highest value is 2 and lowest value is 4. That means it's not certain. But in this case, 4, 5, 6, 7 is given. So this left side part is already sorted. Similarly, this right side part is already sorted. So this should be the condition that we have to check. So what we can do is we can check whether the middle value is less than or equal to the first value. That means 7 is less than or equal to 4. Less than 4. So for example, like suppose the middle value is 0. That is less than 4. So we'll be checking inside this part. I hope you get what I said. So suppose as here the condition says like this will be the middle value 7 after the first iteration. So we are checking whether it is greater than or equal to this one. Yes, as it is greater, then what we have to check whether our target lies inside this 4, 5, 6, 7. If that's the case, we will do the same process recursively on here. Or if that's not the case, as I have said, if the middle value, suppose we will check this, we will take this case 5, 1, 2. Look, take the case of, like, suppose the target is 1. So that's the target I have to find here. So when the target becomes 1, uh, sorry, so the middle, suppose the middle value is 0. Okay, this is not here. Suppose the middle value is 0. I will make it a bit more clear. Okay, so this, suppose this is not here. So 5, 6, 7, 0. So at first iteration this may be that middle value. So this is not greater than the low. As I have said, this is not greater than the low. So what we will do, we will check in this part. We will check in this part whether the target lies here, whether target is in between the mid as well as high. If it is not, we will go here. Similarly, vice versa we will do here. In this case, if the target is greater, as I have showed you previously, if it is greater than the mid value, we will check the target's position, whether it is in the middle of this. So I will show you how it works. Then while writing code, I will give you a better understanding. So basically we are going with the binary search solution. Low will be the zeroth position. High will be the last position. Nums is the array. So the condition to handle the array inside. So we need the middle value, that is low plus high by 2. So at first the low mid will be 7 as I have told now. Now we are just checking if the middle value is, before that we have to break the condition now. If uh, nums of mid, if the mid value is the target, then we are just returning the mid. Now the condition we are giving is if the nums of this mid value as I have set is greater than or equal to the nums of low. So as if 7 is greater than or equal to low, then the condition I'm checking is whether its target is inside this. This is already sorted in that case. That's the trick there. So I'm just checking if, wait, I will give that a better flow. So if that's not the case, I'm just checking if nums of mid is less than or equal to low. That's the other case. So this case is for checking whether 7 is less than or equal to 4, the mid value is less than or equal to 4. And this case is for checking if it is uh, less than. Okay, the first one is greater than, this one is less than. So first, as I said, if it is greater than or equal to low, that condition is true. 7 is greater than or equal to 4. So we are just checking if the target lies in between. If nums of low, that is first one, that is 4, is less than or equal to the target that we have to search, which is less than or equal to nums of mid, that will satisfy the condition, whether the target is inside that. If it is inside, as we are in the middle position, we have to go to the left side. We have to omit the right side, right part completely. So how will be mid minus 1. Yes, we have to go for the next half. Mid plus 1. That's the condition here. Similarly, for this also we have to do the same thing, but the half will be the other one. We are checking if it is less than or equal to mid, whether the target is greater than or equal to mid, but less than or equal to high. So if the nums mid is less than or equal to target, which is less than or equal to nums of high. That's the condition there. If that's the case, our low will be mid plus 1, else the high will be mid minus 1. So that's all about this part. We have one more thing, I guess. Like if it is not there, we have to return minus 1, that will be outside the loop. So I think this is fine. Let's see how it works. Yeah, that's perfect. So as we have said, we have applied a proper binary search here. We are just checking which part it comes, where the target value can be. So that's the idea here. So okay, one minute, this is small error. So in this case, the first middle value will check it. In this case, the first middle value will be 1. So if it is 1, it is not greater than this. So we are just checking in the other half. So basically, it's not found to say we have to return it. So it means the problem lies. Oh, sorry, there was a mistake. Nums. If nums of mid is greater than the first one, if it is less than the row. Okay, guys. So that's all for today. So we'll see you again in another video.